We're here today to bring you a series of 4 talks that we call Hack.Talks. And Hack Talks are basically chats with well-known programmers who have notoriety in the development space. And we think it's an exciting opportunity for everyone to learn and to kind of do Q&A with some of these incredible developers. And so our first developer today is Reuven Lerner. Now, Reuven Lerner is a full-stack web developer, and he's been doing that since 1993. He's also been a Linux journal columnist since 1996. He's an expert and experienced developer. He's also a trainer and a consultant in Ruby on Rails. And he also specialized in PostgreSQL and Python, among other things. He has a PhD in learning sciences from Northwestern University, and he's taught Ruby, Python, and Postgres to thousands of students from all sorts of enterprise-level companies such as Apple, Cisco, HP, SanDisk, VMware in the US, Europe, China, and Israel. And so we're very, very lucky to have Reuven here today. And I would like to now kick it off to Reuven to fill you in for the next hour. And we'll do Q&A afterwards. So take it away, Reuven.
Excellent. Thanks, Ed. Hi, everyone. Glad you guys could make it tonight to join me for this talk. Now that we got through our technical difficulties, fortunately, as technology people, we are very well aware of how fragile software is. Not our own software, of course. It's always someone else's software. That's to blame, or at least that's what I tell my clients, right? In any event, I'm going to talk to you for a bit about certain aspects of functional programming, and specifically certain aspects of functional programming in Python. And I'm going to give a whole bunch of demos and a whole lot of descriptions. Oh, someone's asking, what is a full-stack web developer? So back in the days, back in the Mesozoic era, when I started doing web development, there was just a web developer, right? Or we didn't call it web development, we called it like, webmaster. And it meant that you knew how web technologies work. You knew some HTML, there was no CSS, there was barely JavaScript. We had to light our computers by rubbing 2 sticks together. And then over time, things got more and more complex and more specialized. So nowadays, typically, you talk about 2 kinds of web development. You have the back end, the server people doing servers and databases and so forth, and you have the front end people doing like the JavaScript and the things that actually look nice. And full stack web developer is the way to show off to your friends and colleagues and clients and say, I actually know it all. It's the official way to be a know-it-all, I guess. So like JavaScript all the way down to the database, all the way down to the system. You can cause trouble at front and back ends. In any event, now Python is all, so I do a lot of work in Ruby and Python as well as in JavaScript. I do a lot of training in them. And I found over the last few years that one of the things that I really enjoy most and that is hardest for people to understand when I'm doing training is a type of programming called functional programming. So I thought it would be fun to introduce you folks to the ideas of functional programming, or at least some of them. It's a big field. We've only got an hour, and as fast as I can talk, we still only have an hour or so. So I'm going to introduce you to some of the aspects of functional programming that are available in Python. And I hope that it'll give you some insights into how you can use Python in more interesting and powerful ways. And insights into how programming works in general, programming languages. Now here's the thing. For some people, you'll be like, oh, this is a piece of cake. This is great. Some of you, it's going to seem really strange and hard to understand, and that's normal and that's okay. As I said, I've been training a lot for many years, and sometimes it takes months for people to sort of get this. And once you do get it, it's just amazing. So I'm now going to actually switch off my video. That's it. I'm going to share my screen. Let's see how this works. Screen share. And I'm going to screen. Oh my God, too many screens to choose from. I want desktop number 2. Yes. I'm going to start the screen share. Okay, you are screen sharing, so Google tells me. And now I'm going to pop up my window. And before I do that, I'm going to give you a little ad. So I have just come out with a new ebook called Practice Makes Python, and the basic idea is that after you take a course or learn Python on your own, it does not matter how good the course was, you still need lots of practice. So this is 50 exercises you can use to go through, and I'll But first I want to tell you about a TV show, an old TV show called The Twilight Zone. Some of you may remember it, some of you may have seen it, and The Twilight Zone was this really cool show. It was sort of like, it was sort of before I was born also, right? Don't feel embarrassed. And it was sort of science fiction fantasy with a paranoid streak. And there was always some twist. And one of the most famous episodes was called To Serve Man, where these aliens come from space and they come to Earth and they say, we are here to help people. We are here, to do whatever you want. Look, our guidebook, our official guidebook is called To Serve Man. And they give us health care, and they give us food, and on and on and on. And they invite a whole lot of people to come back with them to their planet. And as people are going onto the spaceship, and as it's sort of too late for them to come back, someone finally runs up, a scientist runs up and says, I've decoded what their guidebook says to it's a cookbook, right? And so the idea is that whereas people thought that they were being served by the aliens, they were actually going to be served up to the aliens. And I mention this because in so many ways, when we are programming, right, in theory, the computer is supposed to be serving us. And so often as programmers, we find that we are doing what's good for the computer and not the reverse. And high-level languages like Python sort of break that trend to say, no, 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 the computer is there to serve us. We want to be in charge. We want it to think the way that we think. And if that means that I can work much faster and better as a programmer, to work a little more slowly, that's okay. And functional programming comes from that school of let's think at a high level. Let's think in terms of ideas. Bits, bytes, disks, RAM, CPU, those are all nice abstractions, but we just want to think in terms of ideas. And functional programming is not new. Functional programming has been around for a long, long time, probably about 60 years since the beginning of Lisp. And it's a different way about thinking about programming. It's a different way of writing your programs. It's a different way like approaching problems. And in many, many cases, it'll provide you with new and clean and elegant solutions. But again, you're going to have to think differently. And so part of my goal here is to help you sort of look at things in a different way. So let's take a really, really, really simple diagram here of what is a function, right? Anyone who's done any programming has used functions, and they sort of look like this if you are a very poor graphic designer. Every function has an input, right? And every function has an output. Technically, every function has to have an output. In Python, that's definitely the case, where if a function does not return a value, it returns a value called none, sort of like the value that is no value. So we can imagine our function is sitting there in the middle. It gets its input. It does some churning. It does some output. And so to hear the term functional programming, you might be saying, so what? Like, all programs are functional, right? So the idea of functional programming comes from the math world, where functions are sort of pure, and they don't do assignment, right? There are no variables if you say f of x or g of x in your math class. There's just an input and an output, and the function does some manipulation. So to sort of qualify as functional programming, you have to have no external state changes in this function. The function cannot be going and changing things in the world, but it also should be trying to avoid internal state changes. And if you've been programming for any time, you're saying, wait a second. You want me to write my functions with no assignment? Are you out of your mind? Like, that's what I do all day. I assign variables. Well, the thing is, it is possible to work without assignment. It is possible to work without changing things. And the big wins you get are your functions become much simpler. They become much easier to write and maintain. They become easier to test. You can predict what they're going to be doing. You can combine them in new and different ways. And then you can split work across threads or processes or machines. Earlier today, I was doing some Python training actually at PayPal here in Israel, where I live. And I was showing them how you can now. It's true that threading in Python is not amazing, but IPython, which is this great interactive shell, has these amazing abilities to basically take a problem, break it apart against different engines, and then bring it back together. And that's really an outgrowth of functional programming. So if you're not going to have assignment, if you're not going to be changing things at all, you're just going to be sort of moving input to output, you end up with this chain of functions. And that's how functional programming looks at the world. I'm going to have a lot of little functions, right? And so it requires a bit more memory, a bit more organization. Your memory, not the computer memory. You need to remember what is where because you're going to have lots of functions to choose from, and it'll be sort of like Lego bricks. You're going to put them together. The combination of these inputs and outputs, functions, will really give you a lot. Now, you might, if you have experience with Python, be saying, wait a second, this is not the way Python works. Like, yes, I can chain my methods and functions together, but Python has assignment, and Python has mutability, right? We have mutable data structures. So to say that's a functional language is just kind of silly. Well, Python is actually a multi-paradigm language. It offers many, many different ways of programming. And so we can do it using functional programming. We can do it using objects, and we can do it with both. We can mix object-oriented and functional programming together in one program. And one that I've adopted from other people, sort of an approach I've adopted from other people is, I now write typically in an object-oriented style. So I write my classes, I write my methods, I do all that. But inside of my methods, I use functional techniques. And I do that because I find that the power that I get from them is really great. So I just want to turn this off for a second and see. People still up? Okay. Oh, your volume. Sorry, I just want to check if there's anything on the chat. Can people hear me? I hope so. And yes, I will say lambda at some point. Anyway. let's go back to some of the screens and so forth. So in Python, we have so Python is not a functional language, but we do have the ability to use many, many functional aspects of it. And Guido van Rossum, who created Python, is not a big fan of functional programming, and it's been this sort of ongoing struggle to decide whether he. Oh, I see. It's not showing me at all. Anyway, it should be it's sort of a struggle how much functional programming stuff should be in the language. So we now have a fair number of functional programming paradigms in the language, and you get to choose whether you want them or not. Yeah, I see that. I know there's a 30-second delay. In fact, you will now see this 30 seconds later. Excellent. Gotta love it. I guess it's only 7 seconds on CV, so they have an easier time with this. In any event, so Python has all sorts of really cool functional aspects, and I want to spend some time talking about one specific aspect that I think is particularly cool in Python, that when you can master it, it's really, really amazing. And I'm not using Vim. I am using Emacs. Please, I went to MIT. We were brainwashed to believe that all good programmers use Emacs. In fact, we were brainwashed to believe that no one actually used Vim anymore, or VI at that point. So when I'm talking about functional techniques, I'm talking about typically working on a list or another iterable, meaning a string or a list or a tuple, but we can also iterate over dictionaries and sets and files. Lots and lots of things in Python are iterable. And that's on purpose. This iteration protocol is something that permeates the language so that if I have an object, I can almost certainly stick it inside of my for loop and use it. Database queries work that way. Many, many objects work this way. So let's assume I want to do a transformation of some sort. Let's assume here I have, let's say numbers equal. Great. Oh, something just happened. Oh, no. It muted my microphone because I was starting to type. Hopefully it will not do that. All right, so I got these numbers. And let's say I want to turn these numbers into their squares. Right? So we know how we can do this in a basic way in Python. Right? I can say, output equals, and here append. It works. I got, oh God. Sorry, I had to unmute my microphone again because I was typing again. Anyway, this will work. We get our output, and the output will have the numbers in squares. The thing is, this is not exactly what for was designed for. And if you're coming from a language without functional capabilities, you might say, what? Of course it is, right? I want to iterate over numbers. I want to get each number one at a time. I want to stick it in the output. And it's true, this will work. As I like to say sometimes, unfortunately, it will work. But you have to think in a different way. For was designed for executing commands a number of times. And if we think in a functional way, we want to think again in terms of those inputs, function, and outputs. Let me see, I think I have a slide here. Yeah, what I want to really do is something like this. I want to have a function, square. And I want to take each list item and pass it through that function and then get a new list item. So at the end of the day, I'm going to have a new list based on the original list, and that new list will have the same number of elements, and each element will have gone through my function. So there are a few different ways that I can do this in Python. But the elegant way, like the way that we are encouraged to use, is something called a list comprehension, or comprehensions in general. Now, I'm going to warn you right now, the word comprehension is a bit of a misnomer. Yes, it is a mathematical construct. It is somewhat incomprehensible first starting in Python. So I'm going to show it to you, and I'm going to try to go over it, and hopefully with a bunch of examples, you'll see some of the power that we have here. So if I want to do the same thing, I want to take numbers, and I want to run it through the grinder of a square function. So I better create a square function, right? Def square. So there I got my function. Oh. And unmute again. Excellent. Good thing I'm not using my loud keyboard, right? And so now I'm going to say, square 5, square 10. Works very well. What I want to do now is say to Python, take each element in numbers and go. So I'm going to say square of numbers. And this is my list comprehension. And when I press enter now, I get a new list back. Now, you might be saying, wait a second, this is the same output as we got here. And yes, that is indeed true. It's the same output exactly, but I did it in a very different way. Instead of iterating over the list and making an assignment with each time or changing the output list each time, instead, I've got this sort of internal iterating thing, what we could call a map function in many other languages, and it's just creating this new list for me. And so I get this new list. You can think of the old list as being mapped to the new one, where each element is the result of writing the function over, oh, sorry, this one and that one. Okay, so we've got our list comprehension here. Now, happening here. Now, I live in Israel, so I often joke that people in Israel have an advantage in understanding list comprehensions because we read from right to left. So I'm going to start on the right here. Numbers, that is my list. And I'm going to iterate over it for x in numbers. One at a time, one at a time, one at a time. Okay, yes, I did put the brackets there. The square brackets are there to indicate it's a list comprehension. And in a moment, I'll show you other kinds of comprehensions. All right, so I'm iterating one at a time over 4x in numbers. Now, don't be fooled. 4x in, this is not a for loop. This is something else. This is a list comprehension. It uses the same words, but it's totally different. What we're saying for each element in numbers, this is the output I want. This is the expression I want. Okay, so that's kind of nice. That's kind of interesting. But so what, right? Well, the so what is I can use any function I want here. I can have that function execute anything. It can go to a database. It can go to the network. It can distribute our function elsewhere. We can really turn this into a truly distributed system just by writing the right kind of function. And so the output from a list comprehension is always going to be a list. Big surprise, right? But I can do anything I want with these functions. So let's try something else. Let's say I want to take all of my numbers, right, and I want to put commas between them, right? So I want to print them out in a string with commas between them. So I might think that I can do something like this. Join numbers, right? Because I can take a list and pass it to join. Join is a method that I can run on my string. So if I say here, let's do A and B, C, unmute it again. That will give me A and B and C combined with commas. So let's do that with our list of numbers. And of course, I'm going to get an error message. Why? Because it's trying to join together strings as numbers. So really what I need to do is I need to transform my list of numbers into a list of strings. I need to say numbers have to go through a function, and the output of the function will be a string. Well, we know that I can run stir on anything in Python. Stir 5 is the string 5. So what I can do is say stir of x for x in list of strings. It's an anonymous list. I've not assigned anything. I've just created this list almost of whole cloth. And now I can say, here's my comma, join. And there we go. Now I've joined the numbers. But I haven't really joined the numbers, right? I've joined the result of transforming them. And there are just lots and lots of examples of where we can do these sorts of transformations and how incredibly useful and helpful they can be. Here's another one. Let's say I have some words, okay? So words equals, this is an example. We always split them into lists. Okay, let's assume that I have, I'm a big fan of E.E. Cummings. Actually, I think Hackhans now, we've changed the logo to be all in lowercase, right? I guess there should be a dot and everything. So I want to lowercase all these words. Well, we know that I can run, ABC, any word, and lower. Well, so let's do that. Word. Oh, now I've lowercased all the words. I ran a transformation there. All right, and so I can run just about any function I want on my system here, and I can, and I can get the output, and it will always be an output being a list. And then I can do other things with the list, so I can rejoin that, right? I can now say, join this. So anywhere you're expecting a list, you can take another list and transform it, and that's the beauty and the power of list comprehensions. But you can do all sorts of other wild, crazy stuff. Let's say that I want to iterate over some files. Let's see, where am I? Am I here? Okay, yeah, we got some files there. So let's take, let's use import. We're not familiar with it. The globbing is the idea that you can use stars and question marks and file names. So if I say here glob.glob, that'll return a list of Python files in my current directory. Well, let's say I want to iterate all over all these files. So really what I want to do is get a whole bunch of files back. Well, that's okay. I could just say open file name for file name I get 4 files back, file objects that I can actually then do something with. Oh, well, what can I do with them? Well, how about this? Or, well, I mean, then it gets complicated. I don't want to sort of complicate things too much here, right? I can say, for, f in, this sort of thing, for line in f. The lengths of all the files in this directory here, or all the Python files in this directory here. Now you might say, wait a second, you're doing for in a list comprehension. Well, yeah, sometimes I'll do that because this is a list that I can do whatever I want. I can also run things a little more interestingly here, but I didn't want to get into like nested stuff and so forth. It's tough enough. Well, let's try another file, my favorite file to do stuff on, which is Etsy password. Okay, so let's open up f equals open. Now, of course, I can read through. I can say f.readline. Well, I can do f.read, and that'll give me. And once again, unmuting. Okay, and I can seek back the file, and I can do f.readlines, which will give me lines in a list. But that also is not necessarily what I want to do. I can say for line in f, I can just iterate over the file itself, and that will give me the file line by line. Instead of f.readlines, plural, I can say line for line, right? And that's just going to give me the whole lines of the file. Okay, who cares? Well, who cares? Let's say I want all the names of the users of my system here, not line, but line.split. And for those of you not familiar with the Unix Etsy password format, it's each line has colons between. So a split on the colon, and that'll give me now a list of lists. But I have to seek to go back to the beginning of the file, otherwise I'm at the end. And I want really actually the first element of that, the 0th element. And now I have a list of all the usernames on my system. Pretty snazzy, huh? Right? With one line of code, because I'm going over the file. For each line, I'm grabbing the first element there. Well, actually, I'm lying to you a little bit. Because if I scroll up here, I don't only have the usernames, I also have a whole bunch of comments here. That's because Apple, in their infinite wisdom, has put comments in Etsy password, unlike any other computer company I've seen. So really, I only am interested in those lines where it does not begin with a comment. Well, I can do that. I can say here, first of all, let's do our seek again. And this is where list comprehensions become somewhat incomprehensible if they were not already for you. And this is where I like to split them up across lines. There's a line split for line in f, and then we add a third line. If not line starts with. So now what am I saying? I'm saying over each line in f. For each line, split it and get and you want the result, you want the expression return to be the first element, which would be the username. But only when it starts with a hash mark, if it does not start with a hash mark. And now if I run this, sure enough, I have the list of usernames without that. Well, that's pretty great. And you can imagine all sorts of transformations that you can do, especially on files, if you do that sort of thing. And the filtering here, by the way, for those of you familiar with Lisps or even some other modern languages, this is the modern Python equivalent to map, and this is the modern Python equivalent to filter or to select. And the combination is powerful. Okay, well let's try something else, because we don't only want to use expressions sometimes from here. Sometimes we want to do something more interesting. So one of my favorite exercises to do with new programmers is Pig Latin. Right? For those of you unfamiliar with it, Pig Latin is a children's made-up language, sort of almost a code language. So def pl word, right? Where we get a word, and I say if character of the index 1 plus 0. If I say pl word A, but if I say pl word of air, it's going to be A. This is classic Pig Latin. Familiar with it? Okay, so now do this to a lot of words. So we still have my words here? Yes, we do. So I can say, it's going to be a little funny because I have the uppercase words there, but fine. Actually, we can change that too. I can say pl word of word dot lower for word Here, I've translated all these words into Pig Latin. Well, which is, of course, exactly what we want to be doing in our programming careers. Well, let's try something else. Let's open up. There we go. Open up. Journal. All right, so if I open it up, I can read it. That returns a string, and I can split it. Back what? A list of words. So I've now turned my column into a list of words. Well, you know what we're going to do. Bad terminal. Let's try this again. PL word for. No, let's do that. No, I missed something somewhere. Okay, let's just retype this. PL word for word in. It's a good thing I know type. I've been using the word CGI in it for years. Let's try, I don't know, 102. Right? So read. Now we're going to do that. There we go. And now we've translated all of the words in my column into Pig Latin, which is, of course, extremely useful. Well, let's join them back together. Right? And now we have translated in one line my entire column into Pig Latin. This is the power of functional programming, folks, translating into Pig Latin. That's what everyone loves to do. Obviously, hopefully, you understand that we're talking here about an example that's not necessarily practical, but if you see the ideas behind it, right? I can take any input source, run it through transformation, and get an output, and then transform it again. And it's just super, super powerful. Let's try something that's perhaps a little more close to home with many of you, which is log files. And this will be, I think, my last example for now, and then we'll open it up for more Q&A. And if you want, of course, I can just keep talking. So many of you might have to deal with log files. So let's see. Do I have a log file here? Yes, I call it text. Here we go. I have a file called mini access log. And here I'm just going to say open mini access log, read. Let's do print on that. And we can see this is an Apache log from a while ago, from a number of 4 years ago, 4.5 years ago already, 5 years ago almost. Right? And each line of this log shows, as Apache likes to do, here's the IP address, here's some more information, here's the date, right, and the timestamp, and so on and so forth. Well, many of you might know that websites have ups and downs, right? Not just in terms of ups and downs of things working and not working, but ups and downs in terms of during the day. So you'll sometimes have things working during the morning. The website will be stressed in the morning, calm during the afternoon, and then stressed again at night. So what I'd like to do is find out the hours at which my website is most popular. And well, in order to do that, this is going to take a few steps. I'm going to take my access log here, and instead of you might hear my neighbor practicing piano. Instead of just getting the line, right? I'm going to say here line for line. So there we go. So now I can get each of the lines. Let's do it. I'm not interested in the whole thing. I'm interested in just part of it. I'm interested in only the hours. I want to know what hours people were really using the system. Well, I will tell you that I've already done this in advance. Let's see if this really works. From 13 to 15. No, I did not do it in advance very well. Okay. Oh, I'm sorry. We have to split it first. Split lists. And now what? Split 3. So I'm only interested in the timestamp. Right? So what am I doing now? I'm taking this file, I'm going through each line, and I'm grabbing just the timestamp from it. Okay, and now from within the timestamp, I'm going to want, because that returns a string, from 13 to 15. I have just the hour at which people were approaching my system. Okay, and then what? Well, I can turn to an int, right? Here we go, now I turn to an int. Now I have integers. Fantastic. Well, sort of fantastic. Like I've got this list of integers. I want to know how many times each integer appears there. Well, have no fear, boys and girls. We can say from collections import Familiar with it. Counter is super cool. We could say counter A, B, C, A, and it'll count how many times each element appeared there. I can say counter of 1, 2, 3, 1, 2, 2, 2. So I can list comprehension here, right, which gives me the number of how many times each hour. It's each hour that appeared. And I can just say counter on this thing. Oh, once again, my terminal is crazy. Not count, counter. Do this once more. There we go. And it's sort of like a dictionary. It's sort of like a dictionary that has keys and values. The keys are the actual inputs that we were using, and the values are the number of times it appeared. So there were at 4 a.m. there were 30 requests. At 5 p.m. there were 30 requests. Right? At midnight there were 4 requests. Okay, well that's kind of interesting and nice, but now what? Well, now I can, let's cheat a little bit and put this into a variable. Is my counter. If I were a real functional person, then I would not do that, right? So now I've got my variable. Now it's sort of like a dictionary, right? So now I want to see how many people were at each hour. So let's do 4 hour in sorted these. Once again, unmuting. And I'm going to say, now what? I'm going to print, let's do it. Oh, I'm sorry, not hour and C. It's hour and C of hour. Here we go. And now I have each hour and how many people came during each hour. Well, let's spruce that up a little bit. Let's make that a little bit nicer for us to read. So we can use formats capabilities in there. In the curly braces, we can say 2. And now this matches up a little bit more, right? Because we're saying that we want 2 spaces for each number. Okay, but these are numbers. And people don't always do well with numbers. So let's not give them numbers. Let's give them a histogram. I'm just going to say times x. Voila. Now I've created a histogram. So thanks to my counter, thanks to what I did there, right, by iterating over those hours and creating that dictionary in that really easy way, I was able to create this really cool thing here. Well, I think it's pretty cool. A few more points. I've only talked about list comprehension so far, but there are 2 other, let's say 2.5 other kinds of comprehensions in Python that are worth knowing about. So first of all, let's say I have my words again, and I want to, well, let's say, let's take our usernames. So I'm going to say line split, all right, for a line in open, etc. So now I'm going to have all of my usernames. Great. Oh, well, what do we say if not line start? Great, so now I've got all my usernames. What if I'm going to want to ask these usernames? What if I'm going to sort of want to query them on a regular basis? Well, it's going to take a while to build this list each time. I don't have to do that. I want to just be able to, here, let's see if I can get my term. There. Hopefully, I'm going to make it a little wider. Hopefully that will fix these problems. All right, so what I want to do now is put this into a variable or keep it around so I can use it in the future. But we know that searching through a list, right, is going to be O of n to the size. But if I have it in a dictionary or set, it's going to be O of 1. So I want to actually take this and create not a list of usernames, but a set of usernames. Well, I can do that. Just say set around my square brackets, and now I've created a set. But that's a lot of work. I have to write the word set, and the parentheses, and the brackets. So in modern versions of Python, meaning I'm using here 2.7, so in 2.7 or in 3, I can just use curly braces here. And if I use curly braces around my list comprehension, it's no longer a list comprehension, it's a set comprehension. Ta-da, I've created a set. And that set is just super easy and nice and fun to work with. And I do set comprehensions all the time. And you can imagine anytime you have a bunch of things that you might want to iterate over or query, and you don't want to do it repeatedly, you want to do a time of O of 1, you can totally do that. Okay, well, maybe I want to do something a little more sophisticated, right? If I can create a set like this, maybe I want to create a dictionary like this too. Well, good news, folks, you can do that. Let's do line split, this, and 2. And now what am I doing? I'm saying, well, I'm going to split the line and get the 0th item. I'm going to split the line and get the 2nd item. And I'm going to put a colon between them. Well, colon between them, if I've got curly braces, that's going to create, yes, you got it, a dictionary. And there you go. That's our dictionary that we can create super easily. And dictionary comprehensions are just fantastic to play with and work with as far as I'm concerned. Um, so that is basically like what we can do with comprehensions. Now I mentioned there was like another half comprehension around. And that's because if I say, let's just take our original example, x, to do here, it's going to create a list of 5 items and then iterate over them. But I don't really care about this list of 5 items. I don't really need them. All I care about is that we can iterate over something. So many times we'll say then x range 5. And x range 5, I mean, obviously for 5, who cares? But x range guarantees that it's not going to create a huge list. If I were to say 5 million, right, you would care if it were a list or if it were just an object. So x range is what we could call, an object that knows how to behave as an iterable. Well, I might want to do that, right? Like, I might not want to give all the lines of Etsy password right away. I might want to feed them one by one to whoever is giving them to me. So instead of saying line for line in open, what I'm going to do, right, because this is going to return me a list, I'm going to turn these into parentheses, turn this into not a tuple, but a generator expression. All right? And a generator expression means it's going to give me each element only when I ask for it. All right, so it's not going to actually calculate that much at once. It's going to take it. It's going to be lazy loading in certain language. I see here that there's a question. What's the difference between a list and a set? There are a few differences. You can think of a set as a list with no duplicates. That's true, as someone answered there. That was a great answer. But it's more than that. You can think of it as a dictionary without values. It's just the keys of a dictionary. So because it's like the keys of a dictionary, they have to be unique, right? You can't have duplicates. Because like the keys of a dictionary, it's O of 1 lookup, and because it's like the keys of a dictionary, it also, everything must be hashable, meaning it must be immutable in Python. So you cannot store lists in a set in Python. You can't store dictionaries there, but you can, and it's typical to store numbers or strings. All right, and that's why it becomes from O, instead of O of n, it becomes O of 1. So generator expressions actually are more pervasive than you might expect. So you might remember back when I was doing my stir of numbers, that worked just fine. And what was I doing here? I was creating a list and then handing that list to join. Well, join does not necessarily need a list. It just needs an iterable. Well, we can give it one. We can give it our generator expression. And now it'll work just fine. And Python here says, you know what, folks? You don't need those. So this will actually work as a generator expression as well. So what's happening is we have our list numbers, and join then asks one at a time for our generator expression to return things, and it does. And then we give it to that, and then I can do the join. I think that about covers what I want to deal with today, at least in terms of the formal stuff. I'm going to turn off my screen share. I know that takes a little bit of time for my voice and my video and everything to come back to you, but I'd love to know if there are any questions, if people are interested in hearing other stuff, what I'm doing. I'd be happy to open the floor, the virtual floor for questions. And now I will wait while things catch up. And if you don't have questions, that's okay too. I'll just be very sad. Okay, folks, I'm getting sad.
Great. Reuven, that's a great talk. Thanks. Have you had a chance to answer? There's one question about the functional techniques changed in Python 3. Have you addressed that one yet?
So no, I did not address that. So that's so first of all, like for those of you who don't know, Python is this really conservative, nicey language where in each version they were really careful not to break backward compatibility. Until Python 3, when they said, folks, this is it. We're breaking everything, or we're breaking enough that people are going to go, go a little crazy. So there is quite like a break in the Python community between 2 and 3. And it's tough. It's a tough one. And one of the reasons that 3 changed things such that whenever you would normally have in Python 2 a list, in Python 3 you get basically a generator. You get one of these objects that knows how to behave. So for instance, in Python 2, if you ask a dictionary for its keys, you get a list of the keys. In Python 3, you get an object that knows how to be iterated over, but it means that if you have a million pairs in your dictionary, it's not going to give you a million long list back. It's going to give you that generator. I hope that explains it well enough.
Yeah, that's great.
I see that there's a question here. How does a set go to O of 1? So here's the thing. In a list, or in a tuple for that matter, if I want to find something, let's say I have A, B, C, and I want to know, is C in there? So I have to go first A, then B, then C. There's no shortcut. You just got to go over it. And so that's O of n. That means it's going to take time proportional to the length of the thing you're iterating over. Well, a dictionary works totally differently. A dictionary, if I want to know if A or B or C is in my dictionary, or in my set for that matter, we're not going to look through it iteratively one at a time. Rather, we're going to compute the hash function on that thing and then jump to the right place there. And that's considered O of 1. That's constant time, because it means that you don't have to worry about how many items there are, more or less. It'll just jump there in constant time. If you have 10 items or a billion items, it'll still take the same amount of time to find your thing. Now, that's, of course, a bit of a lie, right? It's a bit of a lie because you can construct a hash such that, or a dictionary such that, everything gets put into the same slot, and then you effectively make it O1, which you have a lot of collisions. But we sort of hope and expect that that does not happen much. More questions, comments, bad jokes?
I have a couple questions I'll ask you while we wait for the audience to think of some more questions.
Excellent.
So Reuven, why don't you tell us a little bit about how you first got into programming? Kind of curious about that.
Ooh. Oh yeah. So this is a fun story. So you might notice that I wear glasses. They're actually very thin glasses, but I wear glasses. And we figured out that I needed glasses at around the same time as I had double vision. Not serious double vision, but enough that need to be taken care of. So we went to the eye doctor, and he said, do these exercises. And these exercises were terrible, and I hated them, and I never did them. So the eye doctor got a little exasperated, and this was back in 1975. And he said, there's this new thing called an Atari video game system. If you get that, says to my parents, if you get that, your son will work on his double vision without even knowing it. So we got the Atari console, and we had lots of fun with it, and there was a programming cartridge in it, and you could learn to program in BASIC. And very, very quickly I discovered I was just having great fun with that, and I sort of maxed it out. So for a birthday present, I think for my 8th birthday or something, 9th birthday, my parents got me a programming class at a local computer store. And so I show up at the age of 8, maybe 9 at most, and everyone there is literally 30 or 40 years older than I am, because they want to learn how to use a computer to run their business. And running a business with a computer back then meant learning to program. And I just had the time in my life, and basically from that point on, that's how I got into programming, and from that point on I've been doing it every day and helping other people do it too, which is great fun for me.
Okay, great. A couple last questions here, and we're maybe I have time for one more. Let's see, looks like there aren't any more audience questions. So I'll just ask one more question for myself. I want to hear the craziest story that you've seen in your software development career. This could be a bug, it could be a political situation at work, it could be anything that you think of.
Oh, okay. So I'm going to give you two, because I like both of these stories, and one of them is really fast. So here's the thing. I was called in to this client a number of years ago. It was probably 10 years ago. And they had this really goofy, stupid idea, as far as I'm concerned. But it had to do with cell phones. And back then, cell phones were supposed to have cameras. They said, so one day, cell phones will have cameras on them. And people are going to send not just text messages, but they're going to send video messages and animated messages. And we're going to get in on this. And we're going to, we're going to send some, graphics along with it. But they developed their whole thing in .NET and MS SQL, Microsoft SQL Server. So they called me in to implement it in Java. And back then I even claimed to people that I do Java, which I definitely don't now. And I said, I'm going to use Java and Postgres. And I slaved on this for months, and I got it working. I translated the whole thing into Java and Postgres, and they called up, because telecom companies only use Unix. That was the thing. These guys had developed in .NET, but telecom companies only use Unix. They called the company and said, okay, the software is ready. Can we install it in your server? And they said, yes, of course. We're using a .NET server, right? And that was the end of the project and basically the end of the company. So another fun story was I used Etsy password here as my my example, my punching bag in all of my examples. And back when I was at MIT as a student, I was interning at HP over the summer, and so we had 10, 12 engineers working on the central server, and we all had our own workstations, but we really used the central machine. And I decided to use this new shell called Bash. And I was going to use Emacs, of course, to edit the password file so that I could change it. Well, long story short, I decided to use Emacs, but I didn't want to use it in GUI, so I checked the manual page. I did Emacs minus little t Etsy password. If you've never used the minus little t option of Emacs, that's a good thing, because that opens a file as a file. Well, like, what's the problem with that? Well, the problem is that basically it saw it as a TTY, as a terminal, I should say. So it opened Etsy password, read the first line, said, this is garbage, spat the file back out, removing the first line. I didn't notice this. I didn't care. Emacs was doing something weird. I said, fine, I'll go back to work. About an hour later, one of the people in my group says, Reuven, tell me, are you logged in as root? Because none of us can log in as root. That's right. By trying to edit the password file in a stupid/clever way, I managed to erase the root user, and I basically paralyzed my entire group at work for like hours and hours while the IT people came and restored the root user with all sorts of backup disks. And I was strangely enough not given the root password after that.
That is a great story, Reuven. Thanks. Okay, so we're just about out of time here. Really, really want to thank you. Extremely interesting and educational talk. For those of you who want to learn more about Reuven and talk to him more about these subjects, I know there's a couple questions that haven't been answered yet. We are about to post Reuven's Google Hangout link directly into the comments, and you can actually talk to Reuven right now for a few minutes live on video. It'll be private, so you're not going to be actually on camera. No one will see you except for the people who are privately in that Hangout. So this is kind of like mimicking the beehive effect that you see at conferences. So want to go ahead and post that right now?
That's great. I would love that. If people have questions, I'd be delighted to talk to them.
Yep. And then we're going to go to our next speaker in just a few minutes. So everyone, thank you very much. Thanks for Reuven, and we'll talk to you guys soon.
Bye, everyone. I'll go to the Hangout in just a moment. Or is this the current Hangout? Do I stay in the current one?
Yeah, just stay here, Reuven.
I stay here. Okay.
I'm going to
disconnect anywhere,
and the audience can join.
Okay, excellent.